at Medical Sciences Med Easy. In today's session, we want to look at how to prepare acids, whereby you are provided with, and these acids normally come with in a brown bottle, and they come with their original concentrations with a label, and whereby the label always contains specific gravity. They always show you the percentage purity. So it is up to you to use that information on the label to prepare the concentration which you want. So in today's session under clinical chemistry, those ones who are doing pharmacy, and this question is commonly asked in many exams. So you cannot go into an exam minus knowing how to prepare these acids. And even in the laboratories where we are working, we need always to know how to prepare the required concentrations of the acids we need. And I always remind you to subscribe, like the video. The importance of liking the video is to enable to energize us to make more and more. And it tells us that you have understood what you are watching. And always share to others. So, in the question which you want to answer, which is commonly asked in exams, I have used this example of sulfuric acid, where you have received a brown bottle, 1 liter brown bottle, having a label that specific gravity is 1.84 and the percentage purity is 95. And they ask you to calculate or to prepare maybe like 0.1 molar or 0.2 or maybe 0.5 molars or moles per liter sulfuric acid. So that is what we want to look at. And when we are provided with this specific gravity and we have the percentage purity, and they are asking us that to calculate the number of moles of sulfuric acid in this bottle, so we shall use this label, the information from the label. And this label is having this, so we shall see, we have at our hand, we have specific gravity as 1.84. We have percentage purity as 95%. So another thing we shall need is relative molecular mass of sulfuric acid. And so when we acquire this, we shall be ready to attack this question and to prepare these solutions. So what we need is to first look for the relative molecular mass of sulfuric acid, and the sulfuric acid, to get the relative molecular mass of sulfuric acid, where we need to know hydrogen, there are 2, and the atomic number of hydrogen is 1 times 2. Then we add sulfur, which is 32, and it is 1. Then plus oxygen, which is 16 times 4. If I add this, 16 times 4 is 64. That is 2 plus 32, then plus 64. And this one gives us 98. And so the relative molecular mass of sulfuric acid is 98. So that is the first step you do, and always show it in an exam. Do not hide it. Many students have a tendency of doing it as a side work, and they come and put 98 without showing how it has come. So you're always required to show it because it carries some marks. So this is step 1. Then step 2, after getting the relative molecular mass, we need to interpret what percentage purity means, what 95% means. And 95% means 95 grams of sulfuric acid powder dissolved in 100 ml of distilled water. So that is what it means. 95% means 95 grams of the sulfuric acid dissolved in 100 ml of distilled water. But remember, molarity is always in 1,000 ml. So to get molarity, we always need in 1,000 ml. So here we shall say that if 100 mils of distilled water dissolves 95 grams of sulfuric acid, what about in 1,000? What about in a liter, what we call 1,000? In a liter, it will dissolve, we cross multiply, whereby this one is multiplied by this, then we divide by this. You get 1,000 mils times 95 grams, we divide by 100 mils. We want to get the number of moles. We are answering question 1, which they're asking us to calculate the number of moles. And moles are always in a liter. So these 2 zeros goes with this. We remain with 950 grams of sulfuric acid. Always make sure your calculation is talking. So these ones are the ones that are found in a liter. So these are 950 grams per liter. This is what we need. So these are the grams we dissolve in a liter of the solution. So after getting this, which is step number 2, calculating the number or the grams which can be dissolved in 1,000 mils, the second step is now to calculate the number of moles, or what we call the molarity of the acid. So after seeing this, we have now to calculate the molarity, which is step number 3. And the molarity is equal to mass, and this mass should be in grams per liter, in a liter, times the specific gravity of that acid, and you divide by relative molecular mass of the acid given. So that is the formula we use for both molarity and normality. So if they want normality also, you can use whereby normality is the equivalent weight of the substance. So molarity is equal to mass times specific gravity, then you divide by relative molecular mass. And this mass should be in grams per liter. That's why on step 2, we are trying to calculate the number of grams in 1,000, so that we get it in grams dissolved in a liter of the solution. After that, seeing that we already have mass, which is 950, we already have specific gravity, which is 1.84, and we have relative molecular mass, which is 98. So we substitute, we get 950 grams per liter times the specific gravity, which is 1.84. We divide by 98, which is the relative molecular mass of sulfuric acid. And at the end result, we shall get, if we can calculate together, when we have 950, you divide, you multiply 950 times 1.84, then you divide by 98, we are getting 17.84. We are getting 17.84. I'm putting it into two decimal places, molar. You can say molar, or you can say moles per liter. That is, so the molarity of sulfuric acid, therefore molarity or moles, number of moles, is equal to 17.84 moles per liter of sulfuric acid. So this one answers our first question, whereby the first question wanted you to calculate the number of moles in this 1 liter bottle. So we have seen that the number of moles is 17, and this one is going to act as our original concentration. This one is going to act as our original. So this is the original concentration of the stock after using the percentage purity to get 17.84 molar. I told you we can say molar, that is capital N, or the best one is moles per liter. That is the best one we can use. So this is answering the first question. Then the second question, which is B, they're asking us to describe how to prepare 100 mils. So part B, they want us to describe how to prepare 100 mils of 0.5 molar sulfuric acid, and we are going to use this Stokes concentration, which is, so we wanted to prepare it from 17.84 molar sulfuric acid. So this is the question part B. So we already have the volume we need, the required volume. This is the required volume. This is the required concentration, and this is the original concentration. So when we have the required volume, we have the required concentration, and we have the original, now we can easily calculate. Whereby we use RV over O from RV over O equaling to X, whereby X is the number of mils we shall pipette from the original to prepare 0.5 molar. And R is, we already have R as 0.5, so this one will be X is equal to 0.5 molar times the required volume, which is 100 mils. We divide by the original, which is 17.84 molar. So molar will go with molar, and we shall remain with, we're going to remain with 50 mils. We divide by 17.84. And if we get 50 divided by 17.84, we have 50, you divide by 17.84, we get 2.8. Getting 2.8. So the final answer is 2.8 mils of 17.84 molar sulfuric acid. So meaning, after getting this, the 2.8 mils, these are the mils that we shall pipette from the original, from this original, from the 1 liter bottle, which is in the brown bottle with the label. So we shall pipette 2.8 mils of this from this original. Then we shall top up with the distilled water to prepare our 0.5 molar sulfuric acid, which we can use for many tests in the lab. So we shall end up by now describing getting the, before we get the requirements here, we shall need, remember the rule, it says you add acid to water. You add acid to water. The rule says, this is the rule, and never break it. Always add acid to water, but not water to acid. Add acid to water. So this one is going to force us, since we need to prepare 100 mils. So we need to first calculate the number, the mils we need of distilled water. So the mils of distilled water, to get mils of D water to add, we shall get 100 minus 2.8. And this one shall give us 97.2 mils of D water. So this is what we shall need. So under the procedure, after you have got that, the procedure, you assemble the requirements in place, whereby we need a measuring cylinder, we need the reagent bottle, storage bottle, we need the label, and we need also, we need the measuring cylinder. So after doing that, and the conical flask, after doing that, we are going to measure. The procedure number one is, of course, you first assemble those requirements. That is measuring cylinder. the storage bottle, and so on. Then we shall measure 97.2 mils of 17.84 molar sulfuric acid, and after measuring them we add to the storage bottle, add it to the storage bottle, or you transfer and transfer. So you measure and transfer to the storage bottle, and after putting in the storage bottle, that's when you shall add slowly. You add slowly 2.8. No, this one is not of the sulfuric acid, this is mils, and you transfer into the storage bottle, then you pipette 2.8 mils of 17.84 molar sulfuric acid. So you add slowly 2.8 mils. You measure them and add them slowly into this 97.2 mils of distilled water. This one is of distilled water. And after adding it, you mix well and stopper the container, or you cover the bottle. And after covering the bottle, the last thing we do is to label. After covering the bottle, you label the bottle, and after labeling, on the labeling we shall need the name, the initials of the person who has prepared, initials of the preparer, the date of preparation, you indicate the date of preparation, the concentration of the acid prepared, and here on the concentration we shall put 0.5 molar sulfuric acid. You put it on the label, you put the expiry date, and you put precautions. And among the precautions we can put, it is corrosive. It is corrosive, and it is corrosive meaning you should not touch it without protective gears. That is the precautions. And also you can indicate storage conditions. And many students, whenever they ask this question, they tend to stop on the calculation, and they do not describe the procedure, whereby the calculation is taking 5 marks and also the procedure takes 5 marks. So after getting the meals, you have to prepare well. And another thing we have seen many students do is reaching on the label part, and they say just you label, and they do not give the details. So always make sure you give the details whenever you're asking an exam, and even in the laboratory. When we are preparing them, we always need to give the details for more understanding. Because when you just say label, you miss like 4 marks, because each label takes a half a mark. So always make sure you indicate the label. So this is how we can use to prepare. This using the concentrated acid. So we have seen how to prepare number of moles given the label, given the given specific gravity, given percentage purity, and sometimes they give you the relative molecular mass, but when it is not given, you always calculate it. And that's why I'm going to leave an exercise or some homework, which will put the answers under the comment section. Under the comment section, I will expect answers from you. On this exercise we are going to do at medical sciences, because we want to learn together. And this homework or exercise, I want you to describe how to prepare 250 mils of 0.2 molar sulfuric acid given that The specific gravity of sulfuric acid is 1.84, and the percentage purity is 98%. So we are given percentage purity as 98% of sulfuric acid, and the specific gravity of sulfuric acid has remained the same, 1.84. So given these ones, I want you to describe how in your laboratory, how can you prepare 250 mils of 0.2 molar, 250 mils of 0.2 molar sulfuric acid. Thank you so much. I will be glad to see your comments under the comment section. Please always let us participate together, always let us learn together at Medical Sciences Made Easy. Remember to subscribe if you haven't, to like the video if you have learned, and share to others. Thank you so much.